All right, welcome back here. We're doing the review 3.2 section, properties of solids. And so let's get right into it. The main thing about the properties of solids is that we need to make sure that we understand, again, like in 3.1, we are still talking about the intermolecular forces. These are still at play. So recall those were hydrogen bonding. These were dipole. And we also had London dispersion forces, as well as ion dipole. So I think one of the main things just to remind here is that the order, the strength, the way I've kind of put them here, the weakest is the London dispersion force. So let's make sure we identify that right off the bat. So these are the weakest. The dipole is the second strongest, but the strongest here, let's just go to that one here. This is the strongest of these weak interactions. Remember, intermolecular forces are weak interactions. They're not as strong as ionic or covalent bonding, but they are in their own right have a ranking order. The dipole is the middle type of a bond here when we compare the first three. And so here, however, if we're going to consider the ion dipole, remember the ion dipole is actually going to be stronger than the dipole. So in actuality, it actually would fit right there between the hydrogen bonding and the dipole, if we're going to rank them like that, including the ion dipole at the very end. Now, the reason we want to know about these intermolecular forces is because here in this section, we're talking about solids and what's going to keep that solid together. Let's go quickly over the types of solids that you're going to have. And so let's move some of this information over to the side. Let's move this over here. And let's move the title that way as well. And so here, the type of solids here are the following. We had a ionic solid. We had a covalent, or rather here, the better word to use is molecular solid. Then we also had the 3, which was going to be the metallic bonding, or the metallic solid. And then the 4th one here was going to be the covalent network. So those were the 4 types of solids, and just briefly here, the differences between them is that the ionic solid essentially was an alternating pattern of positive and negative. The covalent solid here, these are weaker than ionic solids, but the covalent solid here were just characterized by a covalent bond between the molecules, but you can also have polar interactions as well. So these are covalent bonds that are or interactions, and then also the other thing you can have here is a polar interaction. The solids in the metallic side, remember these were characterized by the formation of alloys. The 2 main types of alloys that we looked at here were substitutional, and the other one was interstitial. The covalent network solids, here these were the types of covalent solids that were the types of solids that were characterized by the most common one here is going to be the carbon. Again, I've repeated this several times already in class, but essentially what we've got here is the arrangement. The covalent solid that is part of this network is that you have a very intricate network of bonding that's occurring between the atoms. The atom in particular are allotropes, and so common here is the carbon allotrope. And so that's what gave rise to the 2 types, the diamond, and on the other case here, the graphite. The diamond is the stronger of the 2. It has the stronger interaction because it has a lot more intricate interactions occurring in 3-dimensional space, whereas the graphite was more of an interaction going based on layers, and those interactions were relatively weak in comparison. And so a common thing about this particular section is that they're asking you which of these compounds or these types of solids would have higher melting points or boiling points or things like that. And so let's go and get into that a little bit and look at that, because one of the things we need to consider is how does it play out. Now, we did address this already briefly in 3.1, but I'll mention it one more time here, and that is the key point here, that as the intermolecular forces increase, this is actually going to have a proportional increase to various properties. For example, you'll see an increase in the melting point of a solid. So if you place a solid, add some heat to it, it'll have a higher level of melting point. So it'll melt at a higher temperature if the stronger intermolecular forces exist in that solid. Same thing would be true with boiling point. That would actually happen. So once you get it into the molten state, it will boil at a higher temperature if those intermolecular forces are there. And other items here with regards to some of the others is the idea of some of these properties, solids are going to be impacted more than others. And so the general types of questions that you'll probably get is going to be more of a, which of these two solids is going to have a higher boiling point, which of these two solids is going to have a higher melting point, or it could be the other way around, which one would have a lower boiling point or melting point. And so as long as you look at the types of intermolecular forces that are occurring there, the stronger forces present essentially will lead to higher pressure, or higher melting points and higher boiling points. And if there's weaker forces of attraction occurring, then obviously those would have lower melting points and lower boiling points in comparison. So that's pretty much it here for the 3.2. So just make sure you review your notes in this section, and we'll see you in the next video where we're going to cover 3.3.